my, can you see my screen now? Training program. Okay, thank you. So this is what we have for this year. So this is the one we are starting now. You can see introduction to CNI solar PV design. This is what we are starting now, which is going to be a month. All right. Now, like I mentioned, you can see that I specified the hours to be 2 hours. Hello, it might be more than that. Like I mentioned, I want to cover everything regarding CNI PV design, the manual method. All right, so now by April, we are going to be looking at the softwares that you are talking about, because after you've known the manual method, trust me, the software becomes very easy. We are going to be looking at SketchUp. SketchUp is actually a layout system. It's a layout platform for solar design. We're going to be looking at OMA. For those of you mini grid experts, for those of you combining, what's it called? Solar, PV, battery, you are combining grid, you are combining diesel. We are going to be looking at the strictly hybrid. Then we are going to be looking at helioscope as well. Then we see AutoCAD. All right. Now, there is no design that there is no job description of a solar design that you will see, that you will not see AutoCAD there. AutoCAD is accepted internationally. So we're going to be looking at that. There are a lot of ways you can do your AutoCAD design. All right. There's a way there are countless of ways you are going to do your AutoCAD SLD. All right. But the way I love an AutoCAD systems to be designed is for it to be readable. Now I'm going to show you an AutoCAD system that I did for a client. It's a schematic, and you're going to see how easy it is to understand. All right. So now let me just show it to you. I'm going to show it to you now so that you can see it. Let me show it to you just few seconds so that you will see what we are talking about. Okay, I'm coming. Let me just show it to you. Okay, you see it now. So this is it. This is it. If you can see my screen, all right, this is it. Very easy to understand. Can you see my screen? Sorry, I don't want. Let me bring out the AutoCAD one so that I can, maneuver. Let me use the AutoCAD one so that it can be easy for me to maneuver. All right, so the AutoCAD is loading. So you're going to see how it is. I'm sure you all know how to use AutoCAD. But the AutoCAD they are going to be trained on is the one that is very, very easy to understand. Even if you show it to a layman, the layman is going to understand. All right, so I'm sure it's visible now. You can see my screen. All right, let me go to the model. So this is it. You'll see it now. Okay. All right, you can see it, right? Can you see the layout parts? Can you see it? So we did see. Sorry, who is this? My Tech Universe, who is this? Hello, who is this? Who is the My Tech Universe? Bashu, can you search for the person and just take the person off? Bashu, did you search for the person and take the person off?
Yes, sir, I'm doing it.
Please, let's mute ourselves. Let's.
Please, that was a mistake. Please. That was a mistake.
Sorry, we are pressed for time and we've not even started. We have a lot to do. Please remove your. Saudi D, your video is still on. Can you take it off? All right, so now let me just share my screen. Let's continue. Let me share my screen so that we can see. All right, so can you see my screen now? Can you see my screen now?
Yes, we can see your screen.
All right, thank you. So now this is the AutoCAD. Now, without me telling you, you can see the battery. Can you see the battery? Can you see the battery? Everything is well detailed. Can you see it's a pylon tech? Can you see? Can you see the battery? Can you see the cables as well? Can you see the series cables? Everything is well detailed. Can you see? Let's go to the battery. Can you see the inverter rather? Can you see the inverter? This is a day inverter. Can you see everything is well detailed? This is a multi-line multi-line where we stop. So then once we are done with that, then the next one we are going to see by July, we are going to see PV layout and simulation of utility scale system using PVKs and PVCs. Now, PVKs is another awesome design. The reason why you must know AutoCAD is because without AutoCAD, you can't know PVKs. PVKs is a plugin in AutoCAD, all right? So that's why we're going to be treating PVKs and PVCs. Once we are done with our PVKs layout, we can export to our PVCs. So that's why we're going to be looking at it. Then lastly, for this year, we're going to be seeing the financial modeling of a CNI PV project. All right. The financial is also very, very important, right? So now, just target this year that you want to dedicate this year to learn. You want to dedicate this year to learn CNI. All right. Now, I'm assuring you that at the end of this year, you can hit your chest that yes, this year is well spent, and you can also say you are CNI PV design experts. And the reason why I'm more focused on the design is simply because once the design is gotten right, then the project execution or implementation becomes very, very easy. All right. So now let's quickly dive to what we have today. Is 20 minutes past 10 already. So I'm going to be sharing my screen now to see what we have today. Now you can all see my screen, right? I need someone to unmute and say yes, we can see your screen.
Yes, yes.
All right, so you can see CNI solar PV introduction. All right, so now this is it. Now at the end of this 1 month free training, this is what we are going to be looking at. I want you to pay attention and I wouldn't want you to miss out. All right, we are going to be seeing CNI solar PV overview and installation process. That is what we are going to be seeing today. All right, we are going to be talking about CNI. You know, let's have a picture of how CNI project is. Some of you must have been passing by a large project and you are wondering, how are they able to do this kind of installation? You know, it is simply CNI, all right? Now then the week 2, which is next Saturday, we're going to be seeing the key components. Now, this is very, very important. The key component that we're going to be looking at is solar PV, all right? You must have been looking at solar. What is there to know about solar? There are a lot to know about solar because it is the main generating component. All right, so we're going to be breaking it down. We're going to be breaking down the solar. We're going to see how the generation moves from different components to the other. Then the week 3, we're going to see the configuration. Configuration is what I mean is we're going to be seeing the DC coupled system, and we are going to be seeing the AC coupled system. All right. Now we are going to be seeing.
Share the screen, please. There was someone who shared his screen, then he turned out.
What's happening? Hello, Bashu, can you hear me?
Yes, I can hear you.
Who is the person sharing the screen again?
Lukman, but you're stuck.
Sorry, Bashir, if you see anyone sharing their screen, just take the person off, please.
All right.
Okay, so now let's continue. So now we are going to be seeing sharing my screen now.
Yeah.
You can see my screen now, right?
Yes.
Yes, your screen.
All right. Okay, good. So now we are going to be seeing we are going to be seeing different installations. We are going to be seeing the hybrid configuration. We are going to be seeing, what I mean by hybrid is you are connecting your PV with your diesel, or you are connecting your PV with your grid. That is hybrid. Or you have solar, you have diesel generator, and you have battery. Or you have the PV, you have the battery, you have the grid, and you have the diesel. So we're going to be seeing the hybrid. Then AC coupled system and DC coupled system. Then we are going to see a case study. I'm going to give you a case study. All right. The case study is going to be from analyzing the data. All right. Then we are going to break down the design gradually. And at the end of everything, I'm going to share you a template which you can be using. Don't worry about, for now, don't worry about PVCs. Don't worry about helioscope. Don't worry about the software. All right, let's focus on the manual. All right, so at the end of the training, you should be able to understand what CNI solar PV is all about and its benefits. You're going to understand the installation processes of a CNI solar PV. It's different from residential installation. Because residential installation, once you're done, you just tell the owner that, sir, I'm done, start using it. It is practically different. So we're going to understand the solar panel, how to understand the data sheets. It's very, very key. All right? Because before you do your design, you need to take the data sheet of what you are using. You need to be able to interpret each component of that data sheet. Then we're going to see the factors affecting it and its connection methodology, either series or parallel. We're going to see all that. Then inverter as well. We're going to see the types of inverter. We have different types of inverter. Then I'm going to show you, when do you know when to use which of the inverters? I'm going to look at that. Then interpretation of data sheet as well. We're going to see for inverter. Then the battery as well. We see the configuration, its types, connection methodology, and the data sheet interpretation. Then we see the types of charge controller and its data sheet interpretation. Then we see the step-by-step approach in selecting the BOS. I'm sure you should know what BOS is. That's balance of system. You can either call it BOS, which is balance of system, or BOP, which is balance of plant. So when you talk of balance of system, I'm talking about the circuit breaker, the cables, the surge protector, the AC and DC combiner. Those are the BOS. So we're going to be looking at each of them. We're going to see how to select the right circuit breaker for a particular installation. We're going to see how to select the right cable. All right. So everything is going to be based on standard, which is IEC. We're going to be using the IEC regulation. That is what we're going to be using to size our cable circuit breaker as well. All right. Now we're going to see how you're going to understand the CNI solar PV configuration and know when it is being applied. I'm sure you understand the configuration that I'm talking about. That is the AC coupled, DC AC coupled and DC coupled. Then summarizing the load data to be used for a system design. All right, I have a lot of load data that I have here. So we're going to see how to analyze it, because that is the first part. The first part in, if you want to start your CNI, the first thing is, how do you summarize the load data of the client? That is the first step. If you don't know how to summarize it, if you don't know the key values that you need, I'm sorry, you won't be able to do it. Because when you do your login, the data, the raw data you're going to get is going to be enormous. There are some values that you don't need there. So you should be able to filter that and bring out the parameters that you need. So it is from the parameters that you need that you'll be able to analyze it and see how you can prepare and optimize them for your clients. All right. So we're going to be looking at that. I'm sure you're all excited. Are you all excited? If you are not,
Yes, yes.
all right. So we have a lot to do. All right. And I need your cooperation. Please mute your mic. I don't want to see your face. I'm sorry you are not seeing my face as well. Augustine, please mute your mic. I don't want to see anybody's face, and I wouldn't want you to see my face as well. We are here to learn. All right. So now let's continue. All right. So now the overview. All right. What is CNI? All right. CNI refers to solar PV system designed to meet the energy needs of commercial business and industrial facility. Now, let me just break it down to you. Forget those grammar that you are seeing there. Now, let me break it down to you. Now, let me give you an example now. If I have a building, I'm at home, all right? I have a building, a residential building, and in that residential building, I have a factory, all right, that I'm producing. So the electrical facility of that place has to power the facility, has to power the bakery, and has to power the residential. As far as I'm doing a business within that facility, that place is no longer a residential. It has become let me just, it's no longer, if I'm going to do an installation there, it's no longer a solar. You need a constant power supply, all right? And a constant power supply comes at a cost. It is very, very expensive, all right? So for you to be able to still be in business, all right, and you are generating power supply, you need to reduce the cost. And for you to be able to reduce the cost, that is where you have your CNI, all right? So now these systems are typically larger in scale than residential. For residential, you can do 50 kilowatts. You can do 20 kilowatt for residential. You can do 40 kilowatt for residential. But when the capacity becomes 100, becomes 200, 500 upward, then it has become CNI. In fact, CNI also they have capacity range, all right? They have a capacity range. So if you have see some business development guys, their target is to wrap up the megawatts. Are you with me? If you are telling them that I have an installation and my load is 100 kilowatt, they might not pay up to you. They can only pay attention to you if they have exhausted all their artillery. Maybe there is no client to reach out to, and they see you, they're out there, they can come to you. But there's always financial capability of it. So just take note of that. Now, they are designed to offset a significant portion of your business electricity consumption, reducing reliance on grid power. All right? So this is pretty straightforward. The reason why we have our CNI is just to offset the cost of grid. In Nigeria here now, we have band A paying 209.5. Those of you that you are not in band A, just be warming up. Everybody is going to be paying heavily for it. I'm sure you know that electricity in Nigeria is highly subsidized. We are not paying the reflective tariff, so it is highly subsidized. So the government can come tomorrow now that they want to increase it. They have the right to increase it, all right, because we are not paying what we should pay, all right? So if they decide that tomorrow now electricity is going to be 300 kilowatts per hour, that's the amount we're going to be paying, we shouldn't panic, all right? That is why we have to integrate. We need to bring in solar PV, to integrate into the system so as to reduce the reliance. So in that case, when we are injecting solar when we are mixing our solar with grid, we will be consuming much from the grid. All right. For example, now, if the energy of the facility is 100, all right, we can offset in such a way that we can install a capacity of solar in such a way that out of that 100, solar can be taking let's say 80 or even 100 while there is not a grid. All right. Then as time goes on, once the energy from the solar is reducing, then your start moving 100, but the more emphasis, the priority is more on your solar. So that is it. Now, the third point is that CNI are often designed to match the energy usage pattern of the business. That is why I'm telling you that you need to do your energy audit for you to know how to come in, all right? Such as your high daytime energy demand for manufacturing or operation. All right, you can see most of banks now. For your commercial building now, let me give you an example now for banks. Banks' operational hour is mostly from 8 to 5. All right. You can see it's daytime. So that is why you have to integrate solar into such facility. All right. They are potential clients for C&I system. All right. So now, by generating their own electricity, businesses can reduce energy bills and protect themselves from rising utility bills. Just like I mentioned, that the government can wake up tomorrow and decide that want to increase the bill to 300. You don't have to panic if you have solar integrating into your system. You don't have to panic. All right. Now, in the same region, excess energy can be sold back to the grid to net metering. We've not started this, but I think we should be starting soon in Nigeria. I don't know if those of you in Uganda, do we have anyone in Uganda here? Do we have anyone outside Nigeria? I'm sure we should. Anyone outside Nigeria? I want to ask, have you guys been selling power to grid? Have you been selling power to grid? Enoch, have you guys been selling power to grid? Just unmute yourself and tell me. I need one person from Uganda, one person if you are from Ghana, if you are from Kenya, unmute yourself and tell us. Allah, you want to say something? Have you guys been selling power to grid?
Yes, I think in Kenya we sell.
Oh, you guys have started selling power to grid. All right, that's good. That's good. Someone else want to help us? All right, Sweden, of course. We know in Europe they're already selling. Someone from Adelaide, I can see that your hand is up. You want to say something? Uganda, not yet. They've not started. Also in Nigeria, we've not started. All right, but there is what we call distributed generation. In distributed generation, that is what net metering is all about. For distributed generation, if I'm self-generating in my apartment or in my factory, all right, and there is excess, I can simply sell the excess to the grid, and through net metering, they will do plus or minus. If I'm owing the grid operators, they will deduct it, and if they are owing me, they will pay me. So that is what net metering is all about. But I'm sure in Nigeria, we are going to start the distribution generation very soon. And I'm sure the process is already on board, where if I'm powering a particular facility, for example, I can be powering bank, all right, then I can sell the excess to a particular cluster, all right. Maybe in that cluster, I can have maybe like 200 houses, that is simply distributed generator. So we are coming there. All right, why not in Africa? What's the problem that African countries can sell? All right, the problem there is poor infrastructure. That is just it. Because for you to be able to sell with grids, the system needs to synchronize. There is what we call synchronization. For those of you that are not an electrical inclined, there is what we call synchronization. And I'm going to break it down. You see, in electricity, there is what we call voltage. We have voltage, we have frequency, we have current, we have phase sequence, we have phase shift. Those are, how do I call it? Those are I want to break it down so that everybody's going to understand. Those parameters that I just mentioned now are the oil. Let me put it like they are the oil that ensure.
Hello, sorry, can you repeat yourself again? Sorry.
All right. So the reason why we've not started enjoying that in Africa is simply because we have poor infrastructure. And what I mean by poor infrastructure is that the transmission line, the power transformers, they are not in good condition. Because for you to be able to sell your power to the grid and the solar parameters, they need to have the same parameters. They need to have the same voltage. They need to have the same frequency. They need to have the same, they need to have the same phase sequence, phase shift. Those are the electrical parameters. They need to have the same. For example, now, let me assume, for example, now, you are integrating, all right? You are integrating your solar to the grid. And all of a sudden, the grid breaks down. What will happen? You'll be able to generate again. And that is loss of revenue, all right? And nobody wants to invest such. You can't invest in such a way that there is grid collapse, and before they can rectify it, it's taking months. Where do you want the investors to get this money from? You understand? So that is the reason why we don't have it yet in Africa. In Europe, in the Western country, they have good grid infrastructure, so there's a lot of investment going on there. But don't worry, we'll get there in Africa, and I'm sure by this year we're going to have a lot of utility scale system where you have grid being integrated, where you have solar being integrated to grid. So we're going to get there. All right, we are going to get there. Let's just be patient and let's keep building capacity. All right. So that is it. So now many businesses adapt C&I solar PV to reduce carbon footprint and meet corporate. Now when you look at this carbon footprint to meet corporate sustainability, I'm sure you all know this. Now let me just tell you this. When you look at this, back in 2015, I want to use Africa as a case study. Back in 2015 or 2012 or back in 2015, 2012, I'm sure you know that we don't have what we call C&I in Africa. Even if we have, it is not much. The reason being that even if you have the idea and you go to a particular facility that, okay, I have this idea, I'm going to reduce your electricity bill by X, Y, Z, the facility manager will not even pay attention to you because he believes that I don't think it's sustainable and I don't think it's something that can be done. You understand? But with the advent of carbon footprint, with the advent of sustainability goals, trying to reduce the carbon footprint by X amount, every organization now have a department that is talking about ESG, that is environmental sustainability and government. They are talking about it. So every organization now have that goals. They want to reduce the carbon footprint. And that is the reason why, even without you going to a particular business, facility that you want to give them a solar system, you want to solarize their facility, they are the one coming to you. So that is the reason why most business development now are more relaxed, because every businesses are coming to them now. They are hot cake now. Every businesses want to reduce their electricity bill. Every businesses want to reduce their carbon footprint. Every businesses wants to, adapt to the ESG goal. So that is just the goal now. And that is why it is very easy now for every businesses to have solar. And also, you can't compare the cost of solar back then to now. You can't compare the cost of battery back then to now. Everything is also declining. The cost of solar back then is more expensive compared to now. All right? Because of what we call economic of scales. You understand? So that is the reason why everything is more okay now. All right? That is the reason why C&I business is booming. All right? So now that is it. Now the government and utilities often offer intensive. I'm sure you know there is incentive for C&I. But in Nigeria here now, if you are importing solar, there is import duty free. You don't have to pay import duty. There is they've waived 5% import duty for solar. That is the government incentive that we are talking about. And I'm sure in other countries as well, a lot of incentives by government. All these are put in place just to ensure we meet up with them. All right. So now let's proceed. Now, what are the types of C&I solar PV systems that we have? We have the soft rooftop solar. Now, one of the challenges, Adeleye, your hand is still up. You want to ask a question? Adeleye, okay, your hand is dropped now. All right. So now we have different types of C&I. All right. Now we have the first one, which is rooftop solar. This one is the cheapest. All right. It's the cheapest form of C&I solar PV because I already have the roof space. All right. So all what you don't need to do is just to ascertain that the space can accommodate the capacity that you want to design. Once you can accommodate it, now don't think now as time goes on, there are a lot of innovative approach that is being put into place regarding the rooftop solar. Now, I'm sure we have for floating solar PV system. Yeah, we also have that, but the percentage is not much. All right, so out of the installations that we have worldwide, I think the percentage of floating should be within 1 to 5%. We don't have much of it. All right, but it's also part of the types of C&I solar PV systems that we have. A lot of innovations is coming on. People are being creative now. Now, there is one design that I did for a particular client. I just want to hint you about it, just to show you the creative part of C&I. It's actually a C&I. It is a supermarket, to say. Now, the client, I've done the analysis, I've done the audit, and the client's load, all right, is far more than what the roof space can accommodate for the solar. And there is no space for ground. There is no space at all. So what do I need to do? Is either I don't do the design, or is either the client don't continue with the installation. Another creative approach that I'm telling the client now is he should reach out to the neighbor building, all right? The neighbor building. He should reach out to the neighbor building. And if he's reaching out to the neighbor building, it's two things. Because there is no building that wants to give out his roof for free. I'm sure you know about it. Nobody wants to give out the roof for free. So it's either the client is paying for the roof of the neighbor, or the client will give the neighbor power. He will supply power to the neighbor. Those are the two things that the client can do. So I've given the client the creative method in which he can do. So it's left for the client to just reach out to me that he has spoken to the neighbor. So this and this is what they're going to go about it. So that is it. So space is very, very key when designing. All right. So now you can install on the roof of commercial or industrial building. I do for businesses with large unused roof space. All right. Now the next method is ground mounted solar. I like this method. All right. Now in Africa, the ground, when you see an hectares of land, you see it as free. Sorry, it is not always free. 1 month tend to be expensive. All right, because you need to buy that land. All right, you need to buy the land. You need to do all sorts of civil work, structural works on it before you can proceed. So ground mount is very, very expensive. But I like it because it helps you to determine what your yield will be from start to finish. You determine the orientation. All right. You determine the tilt. Don't worry, we're going to get to that. When I'm measuring orientation, but when I'm measuring tilt, don't worry. Just accept it like that. We'll get there. I'm going to break down everything for you. We'll get there. Don't worry. All right. So that is it. So that's the reason why I prefer ground mount. But in Western country, in European country, they tend, even if they have the ground mount, they pay for it. All right, so it tends to be very, very expensive. That is the reason why in Western country you see them doing east-west orientation. Don't worry, we are going to look at that. The east-west orientation is very, very cheap compared to fixed tilt. We're going to look at that. Then the next one is solar carport. All right, just like I mentioned, just like the examples that I gave to you, that the client don't have a roof space. Assuming there is a space for carport, I would have suggested that, but there is no space for carport. So this is another one. There is another one that we have. We call it BIPV. How many of you know about BIPV? That's another type of C&I. How many of you know BIPV? BIPV is called Building Integrated Photovoltaic. That is BIPV. That we simply use an amorphous types of module. We just plaster it on the building. It's that type of system is more fancy. It's beautiful because you make it rhyme to your building. But the challenge there is the orientation does not match, so it is not effective. It is not effective and it is not efficient. All right, so that is it. So what are the benefits of C&I? Lower electricity bills through self-generation. Now, let me tell you this. If you are not saving any amount for the client, don't bother approaching the client with your solution. All right. It is not just all about carbon footprint. It is not just all about ESSG. You need to be able to save an X amount for the client. You understand? So that is it. Now, reduce reliance on grid power and protection against energy grid price. Now, the reason why we often have grid collapse, all right, is simply because we have a lot of people connected to the grid. But if some organization or some people are self-generating, the grid is more relaxed and we wouldn't have more of a grid collapse. So that's another benefit of CNI. Significant reduction in greenhouse gas emission. We all know this. Now, demonstration commitment to sustainability, appealing to the customers and investors. All right. We have a lot of investors. There are people that have the money. They are looking for where to channel their money to. If you meet up with them and tell them you have this project, you've done your assignments, you are good to go, investors will put their money. All right. That's the reason why at the end of this program, which is by October, we are going to be looking at financial modeling for CNI. Financial modeling is very, very important. If you've done everything, you've done your design, the design is okay, it's very, very good, you know. If you are not going to be making an X amount of money, I'm sorry, that project will not fly. Are you with me? Even banks are ready to invest. But if after they've done their DD, what I mean by DD is due diligence. If they've done their DD and they realize that, no, this project will not fly, I'm sorry, it will not fly. In fact, I'm doing a course now with RENAC. All right, I'm doing a course now with RENAC, and you know there are a lot of there are a lot involved when it comes to installing when it comes to solar projects. There are a lot that is involved. It is not just all about installing a project. There are a lot of DD that you need to do. A lot. You know, there are a lot. All right, so don't worry, we're going to be looking at part of it in the course of this training. All right, especially when we are doing that financial. I'm going to be talking about the due diligence, because it's just you need to have investors' confidence. All right, investors want to invest. They don't know what is called solar. They don't know what is called inverter. They don't know what is called cable. All what they know is, when you do this, how much am I going to be getting annually? You know, when will I break even? Now, let me burst your bubble now. That do you know that there are some companies that have done CNI installation for facilities 5 years ago, 7 years ago, but the installation is still running as I'm talking to you now. They've broken even. What I mean by that, they've broken even, is that they've realized their investment. So as it is now, they are just cashing out free money. They are just cashing out free money. You understand? It's just like you're investing 100 naira in a project, all right? And you've realized 100 naira the second year, but the project is still running. So that means the third year, the fourth year, the fifth year, the sixth year, up to 25 years that your installation will be in point, you are still making money. Come on, that's free money. All right, so that's the reason why everybody's eyes now is on this CNI. Everybody's eye is now on utility scale. Everybody's eye is now on solar, because there is money there. In fact, it's more than oil money, if I may say. All right. So now these are the benefits. So now you can see solar PV system have a lifespan of 25 years, providing long-time financial environmental benefits. So you can see the cool money that is there for you to, to recoup. All right. So you might not see the real money now, but by the time you are doing the financial modeling, you are going to see the money even before you commence with the project. All right. You're going to see the money even before you commence with the project. All right. So now let's proceed. Now, the scarcity of electricity due to limited transmission capacity of the national grid is usually compensated by integration of fossil fuel generator. Now, in Nigeria, I'm going to speak as a Nigerian because I'm a bona fide Nigerian. All right. In Nigeria alone, the capacity that generator, I mean diesel generator, all right, the total capacity that diesel generator is giving out in Nigeria is in gigawatts. All right. What I mean by gigawatt is around 8 to 14 gigawatts. You can imagine. And in Nigeria, sorry to say because I'm a Nigerian, in Nigeria we have the highest manufacturing company in Africa. We have the highest manufacturing company in Africa, yet our generation capacity is 4.5 gigawatts. That is ridiculous. I'm sure you understand that. That is highly ridiculous. 4.5 gigawatts. That is what our total generation is giving to us. It's not that we cannot go more than that. We can, but due to poor infrastructure that I've been emphasizing on, all right? Due to the poor infrastructure that I'm talking about, that is the reason why we cannot go beyond that. And every now and then, we keep having system breakdown, grid collapse. Now, that is the reason why more manufacturing companies are not connected to grid. I'm sure you know that 96% of manufacturing companies in Nigeria are not connected to grid. The reason is simply because the grid is not reliable. And I'm sure you know what manufacturing is all about. A manufacturing company that is producing shea butter. Let me give you an example. Shea butter, for example, now. Shea butter processes, all right, takes a while, all right. And for example, now, if you are producing shea butter, you need, there's a stage that you need electricity for 6 hours. And if electricity should go off for a second, you revert back to status quo. That means that everything goes back to raw states. So you need another 6 hours again to recover that process. So that is the reason why they wouldn't want such wastages. So that's the reason why they are off grid. Now, since they are off grid, they are paying heavily for the cost of diesel. I'm sure you know what diesel is. They are paying heavily for maintenance of their diesel. That is the reason why some of them had to go from diesel generator to gas generator just to reduce the cost. Even at that, they are still paying heavily for it. So those are the market. That's exactly the market for C&I. When you spot such manufacturing company, that is a potential customer for C&I. All right? You need to approach them. Obviously, by the time you are integrating solar to their system, no matter what, there is definitely going to be a reduction in their electricity bill. All right? They are going to be paying less. So that's the reason why you're there. So now when you look at this chart now, look at this chart. Let me just continue with this before we look at this chart. Now, this chart is talking about Nigeria. It's a case study for Nigeria. Now, a C&I provide companies with a power supply that is more cost effective, just like I mentioned, reliable and environmental friendly than fossil fuel alternatives such as diesel. Diesel is not reliable, especially when you have the manufacturing company in a remote area where logistics is an issue as well. You need to consider C&I PV system. Now, the solar hybrid technology in combination with battery system are widely used these days due to abundance availability of solar. Now, you realize now that, let me just break it down for you. Now, let's say 3 years ago or 4 years ago, we are talking about solar, not PV. You realize that it is simply solar being integrated with a diesel generator or gas generator. You will hardly hear battery. You will hardly hear ESS. You will hardly hear BESS. But when you realize now, the reason why you can't hear BESS as at that time is simply because the cost of BESS is expensive. And when you do your cost analysis, you realize that doing the BESS is expensive, and integrating BESS with your system leads to higher capex. What I mean by capex is capital expenditure. Don't worry, we'll get to that. The cost of the solar, the cost of your battery is more. So when you do your cost analysis, you realize that you won't be able to save anything for the client. Even if you're able to save anything for the client, the return on investment, the payback years can be 20 years. Abba, nobody wants to wait for 20 years. 15 years. Abba, nobody wants to wait for 20 years. Or let me ask you a question. As an investor, if you invest in a project, can you wait for 20 years before you start making your money? I need someone to give me an honest answer. Who can wait for 20 years before he start making his money? Emeka, you can wait for 20 years?
I mean, that's not possible now. That's a lot.
Yeah. No one will wait that long. Sure. Nobody can wait that long. 20 years is more. But as of now, we now have a reduced cost in the battery. That is the reason why you notice that a lot of people are now integrating solar with battery. Because of the economics of scale, the cost of battery has reduced. All right, so that's the reason why a lot of people can now use battery, use solar, everything is now reliable. Now, looking at this graph now, you can see this is C&I grid energy consumption, and this is grid. So in Nigeria, this is your grid cost. This is your total consumption. And out of it, this is what only C&I is taking. That is a lot, around 86%. That is a lot. Now, when you look at this now, this is industries. These are manufacturing industries. We have food and beverages. This is the green is the percentage for power consumption, and the yellow is the percentage for diesel consumption. So you realize that the food and beverages, the consumption rate for grid and diesel is the same. For chemical and you can see it here. So that is to say that all these industries are potential markets for your C&I solar PV. So when you approach them, you're going to reduce the cost of the electricity, and that is what they want. All right. So you notice that by the end of the year, when all these industries are declaring their financial record, you realize that they tell you that they are making loss. And they will tell you that the loss is as a result of the higher percent in the cost of running their system. That's the cost of grid, the cost of diesel. So that's the reason why by the time you are integrating solar into their system, they are going to reduce their costs. All right, so now we are proceeding. It's getting interesting. Now let's see the components of C&I. These are the components of C&I. I'm just going to brief you about this. We're not going to go into details. But in our next class, we are going to go into details. So I will ensure you to come prepared for questions and come relaxed, because you are going to get more on that. So now I'm going to brief you about this. Now this is solar panel. Solar panel is the main component. All right. Is the main component, is the generating component. Others are just wheel. Others are just wheel to transfer that generating energy from the solar to the consumer. All right. So the solar panel is the main component there. So you can see, convert sunlight into direct current, electricity. Now the reason why I'm doing this, I need to break it down. And the reason why I'm not starting with the software is simply because I want us to be creative in this industry. Let's not follow the bandwagon. All right. Let's not follow everybody in, this is what everybody is doing. Let me do the same thing. Let's stand out. And the only way you can stand out is when you understand the rudiments. All right. Now, I'm actually working on a project, and I'm going to carry everyone along. It's a project that is concerning net metering. All right. Like in Nigeria, we don't have net metering in Nigeria, but I want to do it in such a way that it's going to take just a particular cluster. That is the project I'm working on this year. Nobody has done it before. You know, in fact, I wouldn't say it has been. We've done it in. I wouldn't say it has been done in any world before. Let me put it like that. But it's a project I'm working on, and I know it's something doable. You understand? And I can only think about that simply because I know the basics. So that's the reason why I want everybody to know the basic. But I'm going to carry along just like I mentioned. So just watch out. I'm going to be putting the schematics, everything, the financial, everything, the design. I'm going to be sharing the design with you. You know, even the project, if we are going to execute it, because I already have someone that is interested in it, you know, is going to bring in the financials. It's also going to bring in the POC. What I mean by POC is the proof of concept. That is the location that we're going to use. So I'm going to carry everyone along. It's something that has been done, but it's not precisely what they've done, but it's just like an abstract, or it's just like a subtraction of what they've done, just a minute thing that they've done before. So that is it. So let's understand the basic. When you understand the basic, then you can do whatever thing you need to do with your solar panel, with your inverter, with your mounting structure. And in fact, I visited a location in Lagos, and the way the man was able to do his apartment. Now this is why he was able to do his apartment. He wasn't using an inverter. What he's using is just the solar panel and charge controller. But what he now bought a DC, or anything that he has in his house, he's using DC. You understand? So he doesn't need inverter. Do you understand that? He bought the fittings, the lightings are DC. Some of his equipment, his appliances are DC. You understand? So with that, he's able to save some amount of, because the AC appliances that grid is powering is not much again. You understand? So those are the innovative things that we need in this industry. So let's not just follow everybody that just put solar, inverter, charge controller, and connect. That's all. No, let's be different. All right. So now the solar panel is made of crystalline, polycrystalline, and thin film. Okay, one happens at night. He has a battery now. The battery, what is battery? Battery is also giving out DC. So he stores it. So the battery is also giving it at night. So it doesn't change anything. It's still the same thing. You understand? So he uses it at night. Don't worry, by the time we proceed in this course, you will understand, you yourself, you'll be able to create your own part yourself. All right, so now let's continue now. Monocrystalline, we have monocrystalline module, we have polycrystalline module, and we also have thin film technology. There are a lot of technologies that are coming in, so let's be watchful. You know, let's be watchful. We're going to see a lot of technology. But for now, the one that we use for C&I is monocrystalline, and I'm sure we know how we use because of its efficiency. Polycrystalline has a lower efficiency, but it's cheaper. That is the reason why if you want to do residential, you can decide to go for polycrystalline, because for residential, they will tell you, the quote is expensive. So just help them with polycrystalline and you are good to go. Now, thin film for the building integrated photovoltaic that I mentioned, that is what they use. They use thin film technology. It beautifies your apartment, but the orientation and the efficiency is very, very low. I think thin film technology have the efficiency between 5 to 7%. It's very, very low. All right, so now the efficiency ranges from this to this for monocrystalline. The most. All right. So now let's continue. Now, what is monocrystalline? Okay, thank you. But you don't need monocrystalline is another type of, okay. Oh, sorry, my bad. C&I means commercial and industrial. C&I means commercial and industrial. Monocrystalline is a type of modules. When I say modules, I'm talking about solar PV. When I talk modules, there are some terms that I'll be using as time goes on. But before I use them, I will introduce it to you. When I say modules, when I say PV, I'm talking about solar. You understand? So monocrystalline is a type of modules that uses one cell. You understand? So we're going to be looking at that. Can a course breakdown be made available? All right. So if you just be, can a course breakdown be made available so that those of us here that are not engineers can keep? All right. Don't worry. I'll do that. I'll try as much as possible to break it down. Don't worry. I'll break it down. All right. So you don't need monocrystalline. Now let me just share. Let me go online. Google. I want to show you. Coming. Let me show you something. Let me show you. Like I mentioned, we are still going to talk about all those modules and the rest. We're going to talk about that. But I just want you to see that. I just want you to understand each of them one by one. So let me just share. Oh, don't worry. When we get to that, I'm going to explain we're going to see what monocrystalline. That's in our next class. Because we're going to be talking about components of each of them. So in our next class, I'm going to be explaining what monocrystalline is, polycrystalline, and thin film technology. All right. So now let's move to inverter. Inverter converts DC. DC means direct current from your solar panel into alternating current, AC, for use in commercial operation. In our homes, what we use is AC. All right, that's 230 volts, 50 hertz frequency. That is what we use. All right, in America, in America, they use 60 hertz frequency. They use 120 volts single phase voltage. That is what they use. All right. So in our homes, in every commercial building, for example, now if you go to banks, for example, now banks, their ATM uses AC. That's alternating current. Their air condition uses AC. Their Their system, their PC, that's their computer, uses AC. Their photocopy machine uses AC. All their equipment uses AC. So that's the reason why we need an inverter to convert the DC that your solar panel is generating to AC. Without inverter, oh sorry, am I not sharing my screen? Abdulaziz Yusuf, you can't see my screen? Sorry, can you see my screen?
Yes, you can see your screen. Your screen is visible.
All right, Abdulaziz, I think it's your network. Maybe you log out and log in back. All right, so what your solar panel is generating is DC. All right, so assuming what different types of inverter. We have string inverter, we have centralized inverter, we have micro inverter. Don't worry, we are going to talk about each of them, and I will tell you when to use string inverter, when to use centralized, when to use micro inverter. So it's left for you to decide, oh, for this installation, this is what I want to use. With proof, you should be able to hit your chest that this is the reason why I'm using string inverter, this is the reason why I'm using centralized inverter, and this is the reason why I'm using micro inverter. All right, so I'm going to explain that to you next class. All right, when we talk about the component of CNI. Now, the mounting structure, I've explained this before. We have the rooftop mounting, we have the ground mounting system, and we have the carport mounting system. All right, now we're going to talk about that as well. Now, balance of system, which is BOS. You can also call it balance of plants. That's BOP component. Now, what are these? These are very, very key. Now, when you see balance of system are very, very important. The reason why they are very, very important is simply because they can make or break your investments. All right. I'm sure you know that CNI is an investment. when you see, for example, now when you see a manufacturing company, I'm going to use the companies in Nigeria, for example, now. When you see Coca-Cola manufacturing company, when you see 7-Up bottling company, when you see, name them manufacturing company, when you see a paint manufacturing company, when you look at their roof and you see the roof is being solarized, there is no space. All their roof is being occupied by solar. That is an investment, all right? And investors have done that, have made that investment. So now, what can actually preserve that investment? What can actually prolong the longevity of that investment? Remember, I said it's 25 years. What can make that 25 years to be 25 years is your balance of system. For example, now, instead of you to use 6 mm cable, all right, for your solar, you are using 2.5 or you are using 1.5. You can tell me what will happen. That is, your cable will heat up because the current that is flowing through that solar panel is more for that cable to accommodate. So what will happen? That cable will heat up. And once it heats up, what will happen? That is fire. You understand? When fire happens, what will happen? You have broken that investment. You understand? So your BOP, your BOS, which is balance of system, can actually make or break your investment. For cable, for example, now, let me use, for example, your breaker. Instead of you to use 16 amps breaker, all right, and you are using 5 amps breaker because you feel everybody's just using breaker, no need for me to size it. I've visited a particular installation and I'm seeing the road 5 amps breaker. Okay, let me use 5 amp breaker. What will happen? That breaker will heat up because the current that is passing through it. What happened? The breaker might not even heat up. What will happen? It will trip. The reason why I don't want to use trip is simply because we have those that are not, electrically inclined. But let me just use trip. I'm sure we all know what breaker is. Let me just use breaker allows the flow of currents from cable. It allows the flow of current from one location to the other. All right. So the reason why we put that breaker is simply because if an excess current that will damage that equipment wants to pass through, that breaker will trip. It will not allow it to pass through. All right. Now, if you now use 5 amps breaker instead of 40 amps, what will happen? It will trip. It will keep tripping. And if it keeps tripping, that means that current will not flow. Now tell me, will you be able to make your money if current is not flowing to your consumer? No, you will not be able to make your money. Do you understand that? Because when it keeps flowing, the business owner that you are selling the power to will start complaining that what is happening? I can't receive power. And if it cannot receive power, it will pay. The business owner will not pay. And if the business owner is not paying, how do you want to make your money? You can't make your money. You understand? So they are very, very, BOS, they are very, very important. So I'm going to show you industry standards of sizing cable. Now, the reason why I don't do residential installation, and I will explain to you the reason I do this. The reason why I'm not saying residential installation is okay, and I'm not telling you that I don't. If they come to me for residential, what I simply do is I size based on the way I know how to size, and I give them. By the time they are saying it's expensive, I just lock up. I will tell them, go and meet someone that will give you a cheaper one. You understand? The reason why is simply because they are paying outrightly. You understand? So they don't want to. It's not business, and they are not making any loss. So that's the reason why I don't do that. But for C&I, there is money involved, so everybody is very, very careful. So I'm going to show you the industry standard, IEC. We are going to be using that standard to design our cable and I'm going to give you a template. I'm going to give you a template that all what you need to do is just to input the values that you've seen from the catalog. So we're going to be using catalog that you've seen from the catalog. Input those values, then you press enter. The template is actually Excel. So once you do that, you'll be able to know that, oh, will I be able to use this cable or not? If I can't, then you proceed to the next next parameter. Don't worry, I'm going to show you all that. Also, I'm going to show you how to size your breaker. I'm going to show you how to size your combiner boxes. We have DC combiner box. We have AC combiner box. And it is not all installations that we use DC combiner box. I'm going to tell you everything, don't worry. Now, safety devices, like I mentioned, surge protector, circuit breaker, fuses, they are very, very important for safety of your equipment. All right. Now, monitoring system. It is good for you to be able to monitor your system so that you will know when to do maintenance or not. Now, maintenance in CNI is very, very important. For most CNI, okay, John, you want to ask your question? Can you unmute yourself and do that? Can you do that quickly?
Sorry, with all this information you've been giving us, do you have everything on record? Because I'm loving it. Thank you.
So you said, are we recording? Is that what you mean?
Yes, that's what I mean. Yep.
Yes, it's on record.
Are you sending it to individuals or in the group chat?
No. Don't worry, we have a WhatsApp group. We'll drop everything in the WhatsApp group. Then you can download it. You get?
Okay, thank you.
All right, you're welcome. Now, monitoring system. Now we provide real-time data on power generation, system health, and energy consumption. Now I can show you some of my site that I manage. I monitor it in real time. All right. And the reason why it is very, very key to monitor is simply because for you to know what is happening. Now, let me give you an example now. For example, now, if you do an installation, all right, before you do the installation, you've done your financial analysis, all right? From your financial analysis, you already know that for this month, this is what my energy should be. For this day, this is what my energy should be. From your financial model, remember I said that your financial model is prepared even before you proceed for the project execution. You understand? So you already know that, okay, for monthly, this is what I need to get as my energy. Because it is from that energy that you'll be able to know that this is the money that will be getting every month. And at the end of the year, this is the money that I will get. So that means that if I'm getting loan, I should be able to pay X amount for loan. I should be able to give an equity social amount, and I should be able to keep these amounts. You understand? So you've concluded that from your financial analysis. So having that in your mind, now if you are now monitoring, you now realize that one inverter is not generating. If one inverter is not generating, what do you need to do next? You need to move to the sites. That's the reason why for every CNI company, they have field guys. The reason why those field guys is there is that once anything is not in place with the system, they proceed to the site to rectify it at a spot. They have expected time of arrival. Some is 1 hour, some is 2 hours. Rectify it at a spot. There is no need for going and coming. You understand? The reason why you need to do that is because you need to meet up with that monthly energy. You understand? But if you are not monitoring it and you've done your installation, you will realize that you don't realize that 2 inverters, 3 inverters are not yielding, 4 inverters are not yielding, because you've installed it and it is not just installing and you allow it to go. There might be some issues. You understand? There can be an installation resistance there can be a lot of issues that can come up. So once those issues come up, then they can hinder generation. So once they hinder generation, you need to see that, spot that, and proceed to the site to fix it. So that is why among the BOS, monitoring system is very, very key. You understand? So all these BOS, they are going to form your BOM. BOM means bill of materials. You understand? So we are going to see all that. John, your hand is still up. Are you still asking a question, or is from the previous one? John, your hand is still up. Are you asking a question or from the previous one? All right, so now let's proceed. Let's proceed. Now let's see another system. Another component is what is called energy storage. That's the battery. Like I mentioned to you now that it's optional. You can decide to put battery. You can decide not to put battery. And the reason why it is optional is simply because, now let me give you an example now. If I'm designing, let me assume I'm designing 10 megawatts. Let me assume that I'm designing 10 megawatts. By the time you are using an energy storage, you realize that you are expanding the capex. Like I mentioned, capex means what? Capital expenditure. And what that simply means that is the cost of all that projects, cost of all the components, cost of the installation, any expenditure that you're going to make in the cost of doing your project is capex. You understand? So by the time you are bringing in your battery storage, you realize that the capex is much. And by the time the capex is much, it might also increase the payback period. And nobody can wait. This is money that we are talking about. Nobody can wait for, in fact, some organizations, their payback periods, all right, they are years of breaking even. They'll tell you 4 years. By the time they do their financial analysis and they realize that 4 years is not attainable, they will keep tweaking it until they realize that 4 years. But if they cannot realize that 4 years after tweaking it, they let that project fly. They won't do it. All right. So that is why before you can use your battery storage, just know what you are doing. But don't worry, we are going to see all that. Don't worry. All right. So, but just know that energy storage, which is battery, is another component. All right. So, Oladewaju, your hand is up. Ask your question. Oladewaju, ask your question. Ayodeji, your hand is also up. Ayodele, your hand is up, brother.
All right. Yeah, thank you very much for this wonderful presentation. I'm really flowing. I just want to ask a good short question. Talk about this energy storage for a larger system, like you mentioned 10 megawatt and all that. And then are you trying to say, since it's optional, are you going to introduce PV gensets to maybe using generator, hybrid of both generator and solar systems, in order to, since you don't have or since energy storage is optional? Yeah,
all
that's
right,
my question.
thank you. Yeah, thank you. Yeah, you've said it all. Yeah, if battery is not in the system, that means I'm simply integrating solar with my diesel generator or gas generator or grid. You understand? Do you understand that?
Yeah, okay, yeah, I'm flowing. Thank you.
All right. You're welcome. Yeah, John, your hand is still up. Are you asking a question or is from the previous question? Okay, I can see that you've dropped your hand. Ayodele, your hand is up. Do you still want to ask another question? All right, good. So now let's continue. Now this is another one. Another component is grid connection and metric system. Like we have net metric system, allow businesses to export excess electricity to the grid for credit. Like I mentioned, in Nigeria, I think the process is already in place. where if you are self-generating for a business, all right, I'm sure some, and I can see that some companies have already started it, and the financial, I think it's called RMI. I'll make a research and I'll revert to you guys in the course of the training. But I know that it's already in pipeline. They want to start it. What I mean by that is distribution generation. All right. That is where, for example, now I'm powering a bank. All right. Let me assume that the capacity of that bank is 100 kilowatts hour. That is the energy of that bank. That is the energy that the bank consumes every month. I'm assuming. All right. Now, from my solar PV, I have 200 kilowatt hour energy that I'm getting in a month. So that means that I will simply supply 100 kilowatt hour energy to the bank. Then through what we call net metering system, all right, I will supply the remaining 100 to a clusters of location. Then the discos that is in charge of that cluster will be paying me. We are going to do plus or minus. You understand? They will pay. But that 100, I'm going to integrate that 100 with the grid. You understand? So integrating it with the grid, that means that it is the disco that is in charge. But I will have a meter. All right. There is what we call behind the meter. I will have a meter. All right. That is going to be measuring what I'm sending to that grid to power that clusters of location. I'm sure you understand what I'm saying. Don't worry, in the course of it, we're going to be looking at that very well. All right, Adeyinka, your hand is up. John, your hand
We
is up.
cannot see your slide again. Your slide is not showing again.
It's showing. It's showing. I think it's your network.
Okay, it's showing.
All right, John, okay. John, your hand is up.
Yes. Actually, I missed a little bit of what you are saying, but I want to ask: can you synchronize the solar PV with the generator or gas line without using a battery? Did you get me?
I get. You mean, can you synchronize? All right, can you mute your mic when you are done? All right, thank you. So you are saying that can I integrate solar with diesel generator or gas generator without battery? Yes, it's very possible.
Yes,
it's very possible.
Thank you.
You can integrate. Yeah, of course, there are a couple of systems. In fact, if you go to some of these manufacturing companies, John, are you in Lagos? Are you in Nigeria?
Yes, I'm in Nigeria. I'm in Lagos.
All right. You know, if you go to 7-Up, if you go to Ikeja, if you go to Nigerian Bottling Company, there is no battery there. It is simply solar integrating with their generator. That's their generator. They have diesel and gas generator there. So they don't have battery there. So, but the only challenge there is that once there is a power cut off from either the diesel generator or the gas generator, the solar will not work. Do you understand that? That is the only drawback. Do you get that? But if there is battery, all right. So, but if there is battery, if you have a battery system, you have solar, you have diesel generator, you have gas generator. Even if there is no supply from the diesel generator or the battery or the gas generator, the solar will still yield because there is a battery supply. You understand? So that is
sorry, sir. What of where you are in IPIC of your PV? That means the system is not going to work if you have a cutoff with the gas or the diesel.
Even if there's a peak sun hour, as far as there is no supply from the generator, from the generators, the solar will not yield. It will go. It will not yield. Yeah. All right, Joshua, your hand is up. Ask your question.
Everyone. My question now is about this system. Now, in a case where
Sorry, can you speak at I'm unable to hear you.
James said is design system that
Sorry, I didn't hear you, Joshua. I can't hear you. I think your network is bad. Can you just oh God, it's perfect now, perfect.
All right. Fine.
Your line is breaking. Just
I'll just type it then.
yeah, exactly, just type it down. All right. Adenika, your hand is still up. You want to ask a question? Okay. Ayodele, your hand is up. You want to ask a question?
Yes. So I wanted, it's still based on this, based on the PV genset configuration. I want to know if, for example, I want to design a system for an industry that is into operations, though maybe most of the operations is on, they use generators so often, but then like I want to know when to incorporate or to advise for PV genset system, or we just do normal energy storage system. So I want to be very sure of kilowatts are we to suggest for companies or industries.
Okay.
Yeah.
All right. Thank you. Don't worry, we'll get there. Don't worry, we'll get there. That's what I would say. See, this CNI is very, very broad. You understand? That's the reason why I think I said it in the group that we just have to take it step by step. You understand? Don't worry, we'll get there. In the course of this, remember, we are doing manual. You understand? We want to understand the basic of CNI without a software. You understand? Without using Homer, without using PVCs, without using any software. That is what we are looking at now. All right. So we are going to see in the course of this free training. All right. We are going to see your PV diesel genset. So you are going to you'll be the one to determine. I've done my energy. Do you understand, Ayodele?
Yes.
So don't rush. Don't rush. Just calm down. Don't worry. Huh?
All right.
I want to, this class is actually is a beginner. So I want to carry everyone along. You understand? So I don't want anybody to lag behind. But I just wanted to have a goal that at the end of the year 2025, you should be able to beat your chest that yes, I'm an expert. Even when they wake you up, they'll come and do this design for me. You should be able to, from the top of your head, you should be able to tell them that no, this will not fly. No, this will fly. That should be your goal. You understand? So that is the only time your hand is up. Your hand
Yes,
is
sir.
up. All
Yes,
right,
sir.
you want to ask a question?
Yes, sir. My question is about the industrial solar system.
Okay.
Talk about the diesel gen and gas generator. When it's not on, the light will not on. So I just want to ask a question. Like, I thought maybe since we have the sunlight, it should be on automatically. I don't understand that part. I'm new to this. That's why I'm asking the question.
Yeah, good. It will not work because of. Let me give you an example. It will not work because of safety. Now let me give you the example. Now let's assume that your solar is being, you are generating your solar, all right, with you are integrating your generator with your solar. Now if your generator should go off, all right, and your PV is still generating, the voltage that is coming out from the PV can kill or can injure the operator of that generator. Do you understand what I'm saying? It can damage the operator of that. So that's the reason why for safety. That's the reason why for safety precautions, once your generator or your grid or your generators or your grid goes off, automatically your generator will go. I mean, your PV will not generate. Now, remember when we started earlier on? I'm trying to go technical now. Remember when we started earlier on? I mentioned electrical parameters: frequency, voltage, phase frequency, phase shift, phase sequence. Those are parameters. You understand? That is what synchronization is all about. Synchronization simply means that my solar has a voltage of 415. My solar has a frequency of 50 hertz. You understand? Now your generator must have that same frequency. You understand? Must have that same voltage. If it is different, they will not sync. You understand? So now, if your generator is now off, so that means that the frequency is what is 0. That means that the voltage is what is 0. There is no more synchronization. But your PV is, the voltage is still what? 400 volts. The frequency is still 50. But since they are not seeing the same thing, they are opposites. That means that the PV will not yield. The PV will just go off. Do you understand that? So we are going to see that in the course of the week when we talk about PV diesel. So do you understand that? So just
yes, I understand that part. I understand that part. But
so just
okay, the part I don't understand is just like since the reason why the company is employing the use of solar energy, I don't think they should be using gen.
They will. The reason why, for example, let me give you an example. The reason why they are using generator and the reason why they need solar. Let me just hint you, but we'll get there. The reason why they will need solar is simply because for example, now, if the client, Olufemi, you'll be the one to do this calculation for me. I'm sure you are with your phone. I need your phone to press this calculator.
All right.
Good. Now, if the generator capacity, I'm giving you an example, generator capacity is 1,000 kilowatts. 1,000 kilowatts. You've done that, right? 1,000. That's the generator capacity.
Yes, sir.
And the client load is 700 kilowatts. You understand? Now,
yes, sir.
The reason if the generator is carrying the whole 700 kilowatts, it draws more liters of diesel, and since it's drawing more liters of diesel, that means that the clients will pay more on diesel. We pay more on diesel, we pay more on maintenance. You understand? So that is the application. Now, to now bring it is to reduce the amount, to reduce the liters of diesel that the generator is drawing. Because immediately you integrate your PV with your diesel generator, automatically your generator will be doing 25%. We no longer be carrying the whole 700. You understand what I'm saying? So that means that now do your calculation. 25% of 1,000 will give us what?
0.25, sir.
Yeah, 0.25 times 1,000. Do it. What is it?
Okay, sir. 250, sir. 250 kilowatts.
So that means that good. So that means that instead of your generator to be drawing 100% of that load, which is 700, it's now doing 25%. So that means that if you now subtract 700 minus 250, you said 250, right?
Yes, sir.
700 minus 250 is what? Is what?
450.
So that means that if you integrate your solar to that system, your solar will be doing 450, your generator will be doing 250. So because your generator is doing 50, it will be drawing less of the diesel. It will be drawing less liters of diesel. So you can see that you are saving. But don't worry, I don't know the calculation now, but in the course of this training, you are going to see the calculation, you are going to see the savings that you are doing for the client, because I'm going to be showing you the generator chart, because Every generator has a manual, and in the manual, if you are running the generator for 100%, you will see the liters that you are consuming. If you are using the generator for 50%, if you are drawing the generator for 75%, you will see the liters. If you are drawing 50, if you are using 50% of the load, you will see the liters. If you are using 25%, you will see the liters. So we are going to see that in the course of the training. Do you get that?
Yes, I think so.
You're welcome. All right, Mahad, your hand is up. Or mucho.
Yeah, I just want to ask you about, actually I'm originally from Somalia, but I live in Sweden right now. Okay. I just want to ask you, do you have something to establish your system in Nigeria or generally in Africa to frequencies to become stable?
Yeah, so now, what we usually do now is if you are integrating your solar to the grid or generator, in order for you to have a stable parameters, we use controllers. You understand? So we have different controllers from different manufacturers. We have Ecombi is one of the controllers. We have Elom is one of the controllers. We also have SMA controllers. So we have different controllers that ensures power management. You understand? So that when integrating, everything becomes stable. So in the course of while we are looking at the PV diesel hybrid system, we are going to be talking about the controllers. Do you get that, Mahat?
Yeah, I get it.
All right. Olufemi, your hand is still. You're welcome. Olufemi, your hand is still up. All right. Emeka, your hand is up. Ask your question.
All right. Thank you so much. My question is simply, PV is generating in a typical CNI. So I discovered that the load take less of the PV. Why is it like that? Are there priorities?
The load
less of the PV, yes. Say for instance, you have a 1 megawatt PV, okay, and the grid is there, and the load is about consuming about less PV consumption. Why is it like that?
Where did you see it? Have you seen something like that before?
I have a system and monitor it, yes. So
which system is that?
Schneider system.
Is it okay? Now I don't think probably the configuration wasn't done very well, or probably you are not using a controller. But ideally, it shouldn't be like that. Because what is the essence of using solar if the solar will be producing less compared to other? Do you understand that? So I think probably the configuration is not done properly, or you are not using controller. So look at the system very well, and if you are still having doubt, we can look at it together. You can chat me up personally so that we can look at it together. But ideally, it shouldn't be like that. Priority is given to your PV. It can only be like that if the solar irradiance, that is if it is not sunny, maybe in the evening, when maybe around 5 or around 6, when there is no sun, or in the morning, it can only be like that. But during peak sun hour, definitely it cannot be. Do you get that?
All right, thank you.
You're welcome. Julia, your hand is up. I think your hand is up, Julia. Okay, let me just look at the questions from the group, from the WhatsApp. All right, so but before then, let's just try and finish up our slide. Then I'll look at the questions from the. I think we have just. Let's just look at what we have on the slide. Let's just round up everything. Then we are going to look at what we have. If you have any question, just put it down on the charts. You understand? So let's just wrap up what we have on the slide. Then we look at this now. Business model of CNI solar PV. Like I mentioned now, this is the good thing about CNI. You will hardly see a client that's the business, because we have a business owner. All right, the business owner can be the owner of the bank, can be the owner of the factory, can be the owner of the fast food. Those are the business owner. So now we have two business models. We have the first one, which is ownership model and we have the service model. Ownership model is not really rampant, but I would say we have more of service model. And the reason being that the ownership model enables the business owner to buy the assets. All right. So what I mean by asset is the business owner will buy the solar, we buy the inverter, we buy everything. You understand? So after buying it, in fact, he can even pay for the engineering to be done. You understand? So once he has built everything, then he can now lease it. He can now look for engineering company to come and manage it for him for a certain period of time. You understand? After then, or he can decide that the engineering company that have done the installation to train their staffs so that they can be managing the system. So that is the business model. So you can see now the project host, the project, so which is the business owner, is responsible for the entire cost of the system and will engage the service of a solar system engineering and procurement company. You understand? So the project host may request that the solar engineering company build and train in-house personnel to operate and manage the system, or build and operate the system on their behalf for an agreed period of time. So the ownership model is another business model, but it's not really rampant because, for example, now banks, for example, now their business has nothing to do with electricity. Their business is strictly financials. So they will want to take off anything that has to do with power, electrical power, off their radar. They want to take it off, you know. So that's the reason why you hardly see business ownership model. But the one we have in rampant is the service model. And for the service model, we have two types. We have what we call solar as a service model, SaaS, and we have power as a service model. You understand? In fact, out of everything, the sweetest to me, and based on my experience, based on what I've done, the sweetest is power as a service model. And I will tell you, now solar as a service too is very okay, but it depends on the capacity. Now, I will advise for solar as a service, if the capacity is 500 and above, then you can be considering solar as a service. That is when solar as a service becomes financially viable. But if it is 500 below, consider power as a service. Now, I'm going to explain what solar as a service is to you. Now, in this model, the project developer can be a bank, that is a financial institute, all right, delivers reliable power from solar to the project host. Like I mentioned, project host is the business owner. Now, typically, electricity from the solar system is cheaper than the facility blended rate of electricity. Let me just explain this to you so that you will. So now, what this simply means is that a project developer. What I mean by a project developer is that an investor, an investor doesn't have an idea about electricity, about electrical power. You only have the money to invest. A financial institution, they don't have, the technical know-how, but they have the money. They are looking to invest. So the investor or the financial institution requires the service of a project developer. The project developer will be the one to handle everything from start to finish, from the feasibility assessment to the due diligence to the EPC to the O&M. You understand? The project developer will do that. So now, what the project developer will do is to meet up with the project hosts. That's the business owner. Do assessment of their facility, do the energy assessment, know the amount that the client is paying for. If the client is using grid, fine. If the client is not using grid, he will know the grid costs, know the diesel cost, everything. He will blend everything together. Now, for example, let me assume that the client, all right, the business owner rather, is paying for diesel, is paying, let me assume, we already know what grid cost is. Grid cost, let's say the client is in, the business owner is in band A. He's paying 209.5 kilowatt hour. That's the amount he's paying. Now, for diesel, after doing the cost analysis, he's paying, let's say, 500. All right. So now when you add 500 plus the 209.5, when you divide it by 2, you realize that you realize that it's below the grid. It's below the diesel cost, but it's slightly more than the grid cost. So you can decide that you want to bring down the cost to be around 200, or you want to make it to be around maybe 150. You understand? So that is the energy. So that means that once the client is using it, he's paying per kilowatt hour. That is what solar as a service model is. The client is paying per what is used. So that means that if I'm doing solar as a service model for the client, and it is really solar and PV diesel system. You understand? So once it is 7 p.m., once there is no sun again, I'm no longer in business. Do you understand? Because there is no longer sun. It is sun that is giving me my money. So once there is no longer sun, that means that I'm no longer generating. So for solar as a service, the business owner is paying the project developer based on the energy that he is using in his facility. Do you understand that? And the energy is always in kilowatt hour. You understand? So you use solar as a service. It makes sense. That's to me. It makes sense. Financial says once the capacity is 500 kilowatts, once the client's load is 500 kilowatts and above. But if it is below, it doesn't, if it is your first project, it doesn't make sense. But if you have series of projects and you just want to use it as a stopgap, as to augment, then you can decide to try maybe 300 or 200. It actually depends on your financial model. All right. So by the time we get to financial model in CNI, then you'll be able to make the judgment by yourself. It's past, it's 12 already. Hope you can still wait till 12. Or you want us to stop? Do you want us to continue or
Yes, sir. Let's go on.
Let's go. Don't worry, let's go.
Let's go on and take less questions so that we can finish.
Maximum 12:30. Over the electricity supply from the project host. That is the project developer. I'm sure you know what project developer is now, and you know what project host. From the project and guarantee supply of electricity, as well as provide a discount on energy costs as compared to the facility baseline cost. So now what this is simply saying is that for power as a service, what I will simply do is I will take over the whole electricity infrastructure of the business owner. If the business owner is using generator, I can decide to bring in my own generator. You understand? If the business owner is connected to grid, I will take charge of that. You understand? I will take charge of that. Then I will bring in my solar assets. So what I will simply do is that I will do the analysis. This client is using grid, is using diesel generator, and is paying 5 million in a month. That is, I've calculated the grid cost and the diesel. Everything is around 5 million in a month. So, and I'm coming in, I'm bringing in my solar, you understand? Do the installation and everything. I'm taking over the whole supply of electricity. So what I need to do is just to ensure that there is power supply within the client's premises. If there is no power supply, the client will call me. Bros, what's happening? There is no power supply. Then I will send my guy, go and fix it. You understand? So I will guarantee the client X hours of uptime. You understand? There will be an agreement. You understand? We will send an agreement. So, but I prefer this. So once you do that, then you cannot tell the client will not be paying an X amount of money every month Remember I told you that the client is paying 5 million. So because you are coming in, you can tell the client to be paying 3 million. At least you are saving 2 million every month. You cannot do all this and be telling the client to be paying 7 million. The client will not answer you because you are not making any savings for him. So what is the use of you coming on board? You understand? So that is what power as a service is. Now let me just reiterate both of them. For solar as a service, the business owner pay the project developer based on the energy consumption in kilowatt hour. You understand? So they do the consumption. If it's paying, if the energy consumption is 200 kilowatt in a month, then the project developer already have a fixed tariff. Let's assume 150 per kilowatt hour for what he's using. So they just multiply 150 times the energy consumption. That's 200. So that's the amount that the business owner will pay the project developer. Don't worry, we're going to see that when we get to business model. Then for the power as a service, it is really every month as agreed. It can be every month, it can be every quarter, depending on what is there in the PPA. A fixed amount. You understand? So that is that for that. Now for both of them, there must be a break. That's a payback period. For solar as a service, there's a payback period. For power as a service, there's also a payback period, depending on what the model is. So we're going to see all that when we get to there. So now let's quickly move to solar installation. This is another process you need to know if you're going to be installing solar. So now the solar C&I system involves a systematic process that includes site assessments, system design, component selection, installation, and commissioning. So these are the processes for C&I. Now the C&I PV system requires careful planning, adherence to safety and regulation standards to ensure efficient operation and long-term performance. Right? So the system is there for 25 years. So careful planning and adherence to safety is key for you to be able to cash out. Let me put it like, let me use the normal plans, cash out. All right? By the time you've gotten to maybe 3 years, 4 years, 5 years, all right, you've recovered your investment. The rest 20 years is a cash out period. You'll be living large. Let me put it like that. All right, so now this is the first steps. Pre-installation planning. What are the pre-installation planning that you need to do? Then the first step is site assessments. The first step is in the installation process, evaluate the potential site for solar PV installation. Now, what do you need to do? You need to assess the solar assessment. Now, assess the solar resource by determining the availability, sunlight, that's the solar irradiation throughout the year. Ideally, the site should receive direct sunlight without significant shading between 9 a.m. to 3 p.m. Softwares, PVC, SketchUp, PVK, you can see this is the function of those softwares. But if you don't want to use software, you can also do your shading analysis manually. We're going to see that. Remember, I said this free course is manual, right? No software. So we're going to see how to do shading using manual methods. So you can use that to analyze the shading and optimize panel placement. Now, let me just tell you this. I used to have that notion before, but it's no longer. When you see a building, a tall building, and beside it you are seeing a solar farm or you are seeing a solar installation, you are looking at it, you are now wondering that why will someone have this solar array beside such high-rise building? It is very, very possible. And why is it possible? Once you've done your shading analysis and ensure that within 3 a.m. to 3 p.m. there is no shading, you can go ahead and do your installation. But when you realize that between 9 a.m. and 3 p.m. there is a shading, don't do it. You understand? But once you realize that by 4 p.m. that is when you have your shading, 4 p.m., 5 p.m., 6 p.m. there is shading on your solar, it doesn't count. Don't worry, you can still go ahead and do your installation there. So shading analysis is very, very key in doing your site assessment. Now the next one is the roof condition and orientation. Now the roof system, you inspect the roof structural integrity. You don't just install panels on the roof. You need to consider the weight of your panel to the area. You understand? You need to consider that. That is the reason why you need to employ the service of a structural engineer. You know, they will do it, they will confirm if the weight of your system, all right, is too much for the strength of the roof. If it is too much, then you cannot do your installation there. But if after doing the structural integrity and it can fly, then you can go ahead and do that. All right, I'm sure you know that every panel comes with a weight. If you check the solar panel detail, you will see they will put it there 25 kilogram, 36 kilograms. So you see there. Don't worry, we're going to see how to do all this. You understand? Now orientation. Now orientation too is key. All right. Now you mostly hear that. Why am I not getting enough energy from my system? You mostly hear it is the orientation. It is the orientation. It is the orientation. Orientation too is key. That is the reason why I mentioned to you that I prefer ground mount to roof mount. Because for roof mount, the orientation is there. There is nothing you can do. If it is facing south, it's already facing south. If it is facing north, it's already facing north. If it is facing east, it's already facing it. There is absolutely nothing you can do. And you cannot tell the business owner to come and put your roof like this because you want to put your solar system. No, we can't do that. You just have to go by what you have. It's just going to count as losses. You understand? But for ground mount, you determine your orientation by yourself. You determine the tilt angle by yourself. All right? So now, in the northern hemisphere, south-facing roof are ideal. You can see. While in the southern hemisphere, north-facing roofs are preferred. Nigeria now, we are in the northern hemisphere. So if I'm installing my system, that's the ground mount, I will ensure my panel is facing south. All right? Those in the southern hemisphere, like South Africa, your panel should face north. Those in Uganda, I think Uganda too is in northern hemisphere, your panel should face south. If you don't know which hemisphere that your country is, Google is your friend. You can go there and ask. You see all the countries there. Or you are designing for a country in Paraguay. All right? You are designing for a country maybe in Canada, anywhere. You can just ask Google. Google will give you the download. So that is the reason why, as a designer, you can be at the comfort of your home and design anywhere in the world. All right? So now that's it. So now tilt angle is the optimum angle for solar panel. It's typically equal to the latitude of the location. Although don't worry about orientation and tilt angle. We're going to discuss that. There are sites where you can see all that. All what you need to do is just to input those values. You will see everything there. All right. So now let's look at the next one is the load analysis and system title. Now, your CNI is not complete. Your CNI solar PV is not complete if you don't have, if you're not doing load audits. You don't assume that the client should be using 5 kilo. No, you don't assume. In fact, you don't go to the client's facility and start writing. I'm sure you understand what I'm saying. You start writing, you look at the AC, and this is AC 1, 2 horsepower. You write it there. Refrigerator, 180 watts. You write it there. You write all the connected load. Let me put it that you write all the connected load within the client facility. You now decide that, okay, no, this is this. No, you don't do like that. You need to go there and log. All right? Because if you do all the connected load, it is possible for you to oversize. Now in CNI, it is not good for you to oversize, and it is not good for you to undersize. If you oversize, there will be redundancies. There will be a lot of unused energy, unmet energy, and you wouldn't want to do that. All right? And if you undersize, your system will not be able to bring out the revenue that you want. So that is the reason why logging, you do the audits. Go there with the logger. You can put it there for a month. You can put it there for a week. Just get the load profile of that facility. Once you pull it out, then you can now assess. All right? Don't worry. I have a lot of audits, raw data here, which we are going to use as our case study. All right? So ensure you do that if you want to have an efficient and a well-optimized system. And you can also use the electricity bill. That means if they have constant electricity, bill. If you are using the electricity bill, just watch out for where they wrote kilowatt hour. That is what you need. You also need to identify the peak consumption load. The peak too is key so that you can size your inverter. We are going to look at all this. Now, this is the system size. You calculate the required capacity of the solar PV system to meet the energy demand. This is just a glimpse of how you size your solar capacity. This is a glimpse. For example, if an household consumes, if the energy of an household annually, you can see 10,000 kilowatts hour, and the site receives an average of 5 peak sun hours per day, this is what your system will be. Now, what I'm trying to say now is that, for example, now, if the energy for a day from a particular facility is 5 kilowatts hour, that's 5 kilowatts hour. I need someone to just tell me. Let's just play with our brains. Now, if I'm asking a question now, if the energy consumption from a facility in a day is 10 kilowatt hour, now the peak sun hour of that location is 2.5 kilowatts. It's 2.5 hours. Let me put that. It's 2.5 hours. Now, who can tell me what would be our solar capacity? Oh, I need someone to do that fast. It's very simple. What would be our solar capacity? It's just of how to calculate. There are more to it, but in the course of
4,000.
you see it. 4,000 is simply what? 10 divided by 2, right? That's 10 divided by 2.5. That's it now.
Yes, sir.
All right. So that is it. So in the course of the trade, that's just a glimpse. In the course of the trade, we're going to see how to do that. Now, you need to know the budget as well. Estimate the total cost of the installation, including this is simply CAPEX. This is the CAPEX that I've been talking about. The cost of the mantle structure, EPC plus balance of system. I'm sure you know what balance of system is. EPC means engineering, procurement, and what? Commissioning. Inverter, smart inverter, PV modules. You can see that out of all the CAPEX, you can see the energy storage takes 40%. You can see why the rest is sharing it. Out of all the CAPEX, it is battery that is the most expensive. It is the most expensive. So before you bring it into your analysis, you need to think very well. All right, so now let's continue. Now, selection of your components. I think we've talked about these components. The main component of C&I, solar panel, inverter, module structure, battery, monitoring system. We've talked about it. Now, the installation process, that is the next step. Installation process, mounting these panels. Now, if you're going to use your roof mount system, you need racks. You need install the racking and mounting structure on the roof, ensuring it is secured, securely attached to the rafter. Now, using flashing to prevent. Now, if you are doing your installation, there's every tendency that you need to pierce the facility roof. All right, so that's the reason why you need what we call flash band. Flash band is once you are done piercing, you seal it just to prevent water leaks. Now the tilt the mounting structure to the desired angle based on. Now it depends on the roof. If the roof is like a decking, I don't know. I'm sure you know what decking is. Probably they still want to. They just leave it flat like that. They are not using any normal roof structure that we have. It's a concrete roof. You understand? Once it's a concrete roof, that means you can still build on it and determine where your panel is going to face. Though it is a roof but a concrete one, so you can still determine where your panel will face. All right, so now the ground mounts, secure the panel on the racking system using clamps and ensure that they are properly aligned. The reason why the clamps are very, very important is because in case of wind, you wouldn't want wind to blow everything away. So everything has to be secured firmly. Now the ground mount, this one is very, very clean. Now when we do PV case, now do you know the good thing about PV case is that for ground mounts, I'm sure you know we have AutoCAD map. We have AutoCAD map. I'm sure you know that. AutoCAD is very, very broad. It's not the normal AutoCAD that you have. We have AutoCAD map. AutoCAD map will enable you to geolocate. What I mean by geolocate is simply because from the map you can import your location. All right. So when you import your location, you'll be able to tell that this is where I want to start this is the area that I want to have my solar farm. All right. Now, each of your structure will have a pie. I'm sure you know what a pie is. That is, how do I put it? Let me just do this. I'm sure you know what a pie is. Don't worry now, because I'm going to show you everything. Now, a pie is just like a foundation. All right. So now, your PV, when we get to PV case, you're going to see where your PV case, if you have from your installation, if you have 2,000 pipes, what I mean by pipe is that foundation. Just be seeing it as foundation. If I have 2,000 pipe foundation, I can geolocate each of them. What I mean by geolocate is that for each of those pipe, I can have their coordinates. All right? I can have their coordinates. So once I have their coordinates, my installation becomes very easier. You understand? So all what I need to do is just to go to the site as a project manager. I will print everything out, get the civil guys, give it to them. Once I give it to them, they already know that, okay, this particular pile, this is where to stay. This particular pile, this is where to stay. Then my installation becomes very easier. All right. So using your tape rule to do your measurements, all those ones are old school. Let me tell you. Nobody visits for large installation. When you start doing your measurements, it is when you are doing mini grid that you start doing tape rule to do your measurement. But when it comes to large installation, you don't use tape rule. Strictly go there with your coordinates. All right. In fact, we have a machine, a coordinate machine that once it gets to that coordinate, you already know that this is the coordinate where it needs to drill in the pile. So it does that, and I'm good. That is what we call it RAM, ramming mounting structure, RAM, RAM, RAM. That's what we call it. Don't worry, in the course of it, you get to know everything. All right, so electrical wiring, you connect your solar panels in series and parallel. We're going to see all this. Then inverter as well, you integrate your inverter. Then inspection and commissioning. You do your inspection, you do your commissioning. All these things is something that we do in the course of training. Then maintenance and monitoring is also very, very important. For you to prolong the longevity of your system, you need to do maintenance and monitor it as well. You can see routine maintenance, troubleshooting common issues. Then your safety consideration is very, very key. Safety is very, very key because you wouldn't want to destroy your investments. All right, so I think that is where we are going to stop for today. Let me go through some of your questions. Okay. Please stop. All right. As a recommendation to improve the lecture, can the presentation not ask for audio feedback from us? I believe using expressions should be enough. Okay. All right. Thank you, Jeffrey. We'll look at that. All right. I can't see the screen. Am I the only one? I think you are the only one. Probably it's your network. All right. Matt, welcome. Thank you for joining from Sweden. Henry, Uganda. Thank you for joining from, Kenya, we sell. Okay. Uganda have not started net metering. All right, Kenya have already done that. Why not in Africa? What's the problem? Infrastructure is bad. All right, we have floating solar PV plants. It's part of the type of solar, but we have limited percentage of it. How long is the warranty of solar panels in Africa? It depends on the OEM, but we usually go for CNI. You don't go for backyard OEM. You go for tier 1. You understand? Where your warranty is secured. I think some goes for 2 years, depending on your relationship with the O&M. You go for Jinko, JA, Trina, Tier 1. All right? No one will wait that long. Of course, for the return on investment, no one will wait. Nobody. Please, will this lecture starts be shared? Of course, you get it. What will happen at night? At night, it will yield. If it is PV diesel system, at night it will yield. At night, you simply run on your generator. That is the reason why most manufacturing companies move most of their operations during the day, just to optimize the energy from the sun. So at night, they run less operation. What is monocrystalline? Don't worry, you get to know about it. It's a module, solar module. That is what we use mostly on CNI. Full meaning of CNI is commercial and industrial. Can a cost breakdown be? Yeah, I'll do that. When is our next class? Every Saturday, 10 till 12. We've exceeded today's zone. Can you share your screen? We can't see. I think it's your network. We can't see. Are we getting the presentation? Yes. After finish the course, are we going to get a certificate? I will explain that. I can't see your screen. Please, sir. Hope this session is pre-recorded. Yes. A solar get reference voltage from gen. Yes. So that means once the generator disconnects, no more reference voltage, then your solar will go off. Can you buttress more on system not yielding when there is solar? I think I've explained that, but you get to know more than when we do PV diesel. After finishing the coursework, are we getting it? I will explain that. My question goes to those please. Since we are trying to reduce costs using, why can't a system without battery? Don't worry, you get to know. I think I explained it to. I think I explained it, but you get to know more in the course of the training. It's very clear now, making a lot of sense. Okay, we are appreciating 12 p.m. We can proceed. Can we now move on and allow CNA? Okay. Don't worry, let me. I'll answer your question. This is a reference from the question answer. Does the solar panel still generate the same kV at night? No. The lower the radiance, the lower the yield. All right. If there is no sun, the yield will goes up. Even in the afternoon around 12, even when there is a big sun hour, and all of a sudden there is a cloud, so the yield will reduce. I mean outside of sun. Once there is absence of sunlight, it will yield. Once there is absence of sunlight, it will yield, but it will be very minimal. Even if it is raining, there is yield, but it is minimal. All right, check your internet quality. Okay. But my solar cannot generate voltage at night. Yes. Refer me, the solar panel do not generate at night. However, solar panel can integrate with backup system for using, and that's yes. You can integrate it with generator. Your battery. So at night, what you are using is your battery. Okay, please go on and take the next question. Uganda is in between both hemispheres. Really? All right, don't worry. We'll check in our next class. We're going to check online to see it. All right, can we get the recording? You get it. It's a recording of the lesson being taken because of sure. Thanks for the training. Great training. Go so. All right, we appreciate for your time. With European standard, the warranty 12 years on solar panel. Really? Wow, that's nice. Thank you for the great training. When can we start the course? And is there? Okay. Please, sir, we will be glad. We're glad to attach the recording video. Sure. Okay, I think that's all. 30 years warranty and effect guarantee. Wow. All right, I think we'll talk later, Mohab. All right, so if you have any question, unmute yourself now and ask sharply, because I want to take this off by 12:30. I promise 12:30. So if you have any question, unmute yourself and ask. And I want to advise, if you can join the class, it's better you join instead of relying on recordings. Because at times, the recordings might not be clear. Because we've had a case like that the recording wasn't clear. So if you have the time to join, I will advise you to join. All right, so if there is no question, all right, Mahad, you can raise up, you can ask your question now.
can we get or can I get the PDF documents that you are showing now on the screenshots?
Definitely, you get it. I will drop it. You all get. Now this is it. We have a Google Drive that everything is going to be attached. The PDF, that's what I'm presenting now, and also the recordings. So once everything is done, then we'll put it in the Google Drive. We'll share the Google Drive on the WhatsApp group. So download it, then you can listen to it. Just to be, all right. So now that is it. So for AutoCAD, of course, I've shared. Let me just stop sharing. Hello, can you hear me?
Yes, we can hear you,
sir. Joshua, your hand is up. Ask your question briefly.
Yes, sir. All right, sir. Thanks for the privilege, sir. My question is just on the energy audit. Okay. You made mention of like people that do residential installation that we should not oversize or undersize, and you made mention of like writing the vote of the appliance before the installation that is not really proper. I don't get that very well. I just need more clarity on that.
So this is it for C&I. I said for C&I, you don't go to the facility and be writing. The reason why you don't go there and be writing is simply because all equipment are not operating at the same time. By you writing it, that there is what we call connected loads. You understand? By you writing it down, what you are noting down is the connected load. And in fact, some load might not even operate for a month. But if you note them down, you realize that you are oversizing. You understand? And when you oversize, you are oversizing the capacity. And when you oversize the capacity, you are increasing the capex. And by the time you increase the capex, you realize that the amount you want to be charging the client cannot pay. And that is you've lost the client. But when you go there with the login will be able to show you the profile. You'll be able to see that from 8 to 10, the clients have more operations. You can also see that maybe you notice that in the afternoon the client is not operating, but at night they are operating. So what you need to do is that you will now advise the client that you notice that from the profile, from their load profile, you notice that they operate more at night. You now advise them that why not move most of your operation in the afternoon. Advise them like that. Once you advise them, then you can do your login again. You will notice that everything has changed because you need more operation during the day because your generating component, which is solar, works during the day. You understand? So when you log, you'll be able to make good decision. But if you are writing it down, you can't make any decision. You understand? So that is that. Consult, your hand is up. You can ask your question.
All right. Thank you, sir.
Yeah, you're welcome.
Yeah. Sorry, my question is on for some of us that does not have knowledge of AutoCAD. Okay. Do you also do training on AutoCAD, sir?
Yes. I'll explain that later.
All right. Thank you, sir.
Yeah, you're welcome. Abdul Quadri, your hand is up. Ask your question. Abdul Quadri, ask your question. All right, so let me just continue. Let me round up. So for those of you that didn't join from the beginning, I explained to you that this training is a marathon, not a sprint. All right, and we have a lot to cover. Can you see my screen now? And I told you that I've drafted out a training program from this year. Consult, I'm sure you can see it. So what we are doing presently now is introduction to C&I, which will take a month. Now, by April, we're going to start with the software. We're going to be using, we do SketchUp, we do Hummer, we do Helioscope, and we do AutoCAD. Now, if you've not done this, I'm sorry, you won't be able to do Hummer, Helioscope, and the rest, because I'm going to be bringing in professionals that will take this. I won't be the only one taking all this. So you need to be able to know how to SketchUp now. If I'm going to be taking, I won't be able to tell you that you are trained, you do this. I'll just go straight, because I must have assumed that you've done this introduction. You know the manual method. So without manual, there is no how you'll be able to do Hummer. There's no way you'll not be able to do Helioscope. You won't be able to do AutoCAD. So that's the reason why I'm good. So there are trainings which are going to start in April, July, and August. We want it up with financial model. So at the end of the year, you should be able to hit your chest that I'm a CNI expert. All right. Now, this particular one is free. Now, some of you asked for certificates. Now, there'll be a certificate at the end, but it is not compulsory. All right. The reason why the certificate is necessary is simply because by the time we are doing this, we are proceeding with the rest of our training, there will be a discount, all right, for those that have the certificates. But if you don't have the certificates, you won't be paying discounts. All right, so there's going to be a lot of discounts for those, a lot of discount for those that have the certificates. All right, so that is how it's going to be. So the certificate is just 10,000 Naira. We are going to do the conversion to order for those in Uganda, Kenya. We are going to do the conversion and we are going to share it in the WhatsApp group. So stick to the WhatsApp group. More information is going to be pasted on the WhatsApp group. So if you don't have the certificates, you won't be liable to the discounts. All right. Again, the certificate is 10,000 Naira for those in Nigeria. For those outside Nigeria, we're going to get the exchange rate and share with you. So that is that. So any question? Now the
yes,
training for the software.
Hello,
All right. Yeah, I can hear you. All right, ask your question.
You called me. Now, the question I wanted to ask is that thank you very much for the class. The question I wanted to ask is that you are talking about the reference voltage of the inverter. I think that the battery is going.
I can't hear you again.
To give the inverter the reference voltage. Or
Yes.
you are trying to tell us that in
Yes.
CNI we are not going to. In CNI we are not going to use battery for it,
you.
or what?
I understand. Let me reiterate. Let me just reiterate what I've been saying. What I'm simply saying is that for CNI, I can have a CNI without battery. I can do PV diesel system. If I'm doing PV diesel system without battery, once my generator is not running, my PV will not generate. All right. But if I have a CNI system where I'm integrating battery, you understand? Even if my generator is not working, there is no grid, my PV will still be generating because of my battery. My battery will provide all the necessary electrical parameter that the PV needs so it will generate. Does that answer your question? Does that answer your question now?
Yes, sir. But the network is bad here. I can't hear you.
Okay, I'm saying.
But I don't get you right.
No. What I'm saying is that you can use. I'm saying that if you are not using battery for your system, once your generator is not producing, your PV will not produce. But once you are using battery for your system, the battery will give the reference voltage and your PV will yield. Does that answer your question now?
Yes, sir. Thank you, sir. I understand it.
All right. Abiodun, your hand is up.
Yes, okay. Thank you for that wonderful presentation. So you are talking of certificate and payment and other. I didn't get it. Is it for this presentation or what?
No. What I'm saying is that this training, we have a free training that will span for a whole month. We've started today now. It will end last Saturday of February. All right. So, and I've itemized everything that we're going to be discussing in this free training. All right. So, and I'm saying that certificate for this training is not free. So I'm saying that certificate is not compulsory. All right. But if you want to have it, then if we'll be having our subsequent training, which I've just shared you for April, we'll be having SketchUp, Homer, Helioscope, and AutoCAD. For July, you'll be having PVKs and PVCs. For December, October, we'll be having financial model. You are going to be paying a subsidized amount. All right? You are going to be paying a subsidized fee if you have the certificates. Do you understand what I'm saying now? Do you understand what I'm saying now? But we've just started the training. Next week, we are going to have another training. We have trainings, free training throughout the Saturdays of this month. Do you get that now?
Okay, so let's also know the amount that all this further training will cost, so that we can also be planning for it. I said the further training that is going to.
Of course, like I mentioned, you're going to pay a subsidized amount, and the subsidized fee can be as. Now, I won't tell you the subsidized fee, but if you are not paying for if you are not having the certificate, you can pay as high as 70,000, 80,000, 90,000, depending. But if you have the certificate, obviously you pay far less than that. All right, so engineer, sorry, you need to ask your question quickly because my system can go off any moment from now. If I'm unable to answer your question, maybe you can drop it in the WhatsApp group. Engineer, 30 seconds, ask your question.
Thank you, sir, for the wonderful presentation. The question goes as, will this free training capture the installation aspect of the solar PV?
Yeah, of course, this free training, if you are based in Lagos or you are in Ibadan or you are very close to where I have an installation, like I mentioned, there's going to be a site assessment to see how everything is. You understand? And if, of course, I have my networks, I have installation going on, and if there is any installation that is going on, I will definitely bring it to the group. If you are interested, if it is within your location, obviously you can join. You understand? And in the course of the training for the year, obviously, if there is an opportunity, I'll bring it to the WhatsApp group. You understand? If you need a job appointment, if it is an intern, you want to try yourself, I'll bring it in. I have friends that comes to me that they need a design engineer. I will definitely recommend people from this group. You understand?
Okay, sir. Okay, sir.
All right, you're welcome. All right, Olufemi, sharply, 30 seconds.
Yes, sir. What do you mean by login? We are talking about login.
Okay, cool. Login means that I have an energy, I have a power analyzer. Power analyzer, you take it to the site client facility, and you don't worry. I have one. I will share it in the WhatsApp group after this class. You will see it. You put it in the client. You take audio. It will extract as the client is using his energy. It is extracting all the energy and logging it. Is logging it in its cloud because the logger has his own. It has its own storage. So as the client is using his energy, it is saving it in the storage. So I cannot pull it out, then analyze it myself. Does that answer your question? All right,
yes,
Ibrahim. Yeah, Ibrahim Danjuma, your hand is up.
Okay. Thank you very much for the wonderful presentation. Quickly, so regards to a system that is integrated with a DG and also backup system. So, in the aspect of sizing this kind of system now, so how do one tend to size this kind of system? Thank you very much.
All right, thank you. So if you are sizing this kind of system, you need to consider what the OEM of the generator says about the generator. All right, we are going to look at that in the course of this food training, because every OEM says that there's a minimum genset loading. You must not run the generator below a certain percent. So once you understand that, then you design your PV based on that. So we're going to look at that in our course of the training. Do you understand? Don't worry, we're going to see everything in this free training. All right, Abdul Sadiq, your hand is still up. Abdul Sadiq, your hand is still up. All right, so I think our time is fast spent. All right, so now let me just say this. Though the training is from 10 till 12, but I'm going to beg you, we might spend more than that. All right, because we have a lot to cover. You can see the direction you are giving to me now, PV diesel, you are even taking me to the direction that I never planned to. So we might be spending more than the 2 hours. So I'm going to ask you, are you ready to ride with me? If you are not, just say now so that you back. Are you ready to ride?
Yes,
we
are ready. Go ahead, sir. We are with you.
All right, good. So thank you for your time. I appreciate your time. So we are going to start proper next week. We are going to be looking at the components. So next week is going to be interesting. We are going to be looking at the components. Next week is going to open your mind to the world of solar. You're going to see everything. You will begin to be picturing how everything is going to be like. I don't know, your hand is up.
Yes, please. I would like to work with you concerning this because I have a design to do on one industrial firm. So I don't know if you can be in the loop so that.
So now this is what. Now let me just tell you this. Let me tell you this. If you have any, my phone is available. My WhatsApp is available for anybody. You can always chat me up if you are faced with any challenges with your designs or anything. Always reach out to me. I'm open. You understand? So if you have any design that you are going with and you need my inputs, just reach out to me. Oh?
All right. I really appreciate it. Thank you very much. Yeah.
All right. So I think this is where we draw the curtain. So Abiodun, your hand is up.